Well, thanks very much for that introduction, and thanks for inviting me to be here with you this morning or this afternoon for most of you, I think. Let me just adjust my slides so you guys can see the screen that I'm sharing properly. Yes, just give me a thumbs up there. All right, perfect. All right, so I'm very excited to be here with you this morning to talk about this project. As Volker suggested, this is a paper that I maybe a year and a half ago had presented at a workshop at Penn to him and a few others as a incredibly early stage sort of half-baked set of ideas. It has progressed. What I'm going to talk to you about today is the paper that is available on SSRN with its Friction and Design Regulation as 21st Century Time, Place, and Manner Restriction, co-authored with Susan Benesch. And it should be published sometime this year with the Yale Journal of Law and Technology. But I also want to emphasize that it's really a one work in progress among many. I think this is sort of there's a series of projects co-authored with a variety of people that I just want to mention real quick, and I'll talk about some of them perhaps as we go, and maybe in Q&A at the end. So there's a couple of projects with Paul Ohm, who's a professor at Georgetown in law, and he's a computer scientist as well. And so we're looking at friction and design in the context of in two different contexts, really. Right now, one is in the context of governance schemes at human-computer interfaces and between systems as a way to using friction to establish the opportunity for governance. And we're also looking at the use of friction in design in the context of algorithmic amplification on different platforms. And so that's sort of also building in this set of projects. And then with Madeline Sanfilippo, a frequent co-author of mine, we work together on a book series really on governing knowledge commons. We have a book coming out this year in like a couple weeks on governing smart cities as knowledge commons. And in the course of that book, a series of case studies that use the GKC framework to study knowledge commons in smart cities, Madeline and I sort of explore sort of a decision-making framework for cities on the adoption of smart technology. And I just mentioned that because it's not directly about friction in design, at least it wasn't initially conceived that way. But the more we worked on the paper, and there's an offshoot of that paper that we're also working on, we found that in order to enable slow, deliberative governance, you often need to inject friction into the design of not just technical systems, but also your decision-making and social systems. And so there's a relationship there that we're exploring as well. Finally, before I jump into the talk, let me just note that Volker and I were talking about this before we started. It used to be friction by design regulation, and we've switched to friction in design regulation. And I thought I might explain why. So Paul Ohm basically convinced Susan and I in a long conversation about why friction in by design was probably going to be a confusing term. Simply because the way people understand existing concepts like privacy by design and security by design. In those contexts, privacy and security are the ends, right, to which design serves as a means. And even in those contexts, I think sometimes the end is a little unclear, but you get the point, I hope. I want to be clear, we don't hold friction to be an end worth pursuing in and of itself, right? Friction is instrumental. And so an important contribution of this article, I think, is to propose a descriptive framework for evaluating and comparing how different frictional measures can be instrumental to a variety of different social or private goals. And so since we're focused on frictional design measures that introduce one or more different types of friction, we opted for this more descriptive label, friction in design. All right, so let me proceed. Here is what I want to, I'm just going to advance the slides. There we go. So here's the basic outline of the talk. It follows the outline of the paper. I want to start with introducing our basic claim about digital network society needing friction in design regulation. Then I'm going to jump into explaining a little bit more what I mean by friction by, I fell into it. I said friction by design. I meant friction in design. I'll say a little bit more about what I mean by friction in design and what we have in mind in terms of friction in design regulation. The third part of the paper deals with the First Amendment analysis. In part, this paper with Susan was written to sort of deal with the First Amendment's preemptive effect on any kind of regulation, certainly proposals about friction in design regulation. It both preempts actual proposals, but it even sometimes, I think, preempts regulatory imagination. And so the third part of the paper deals with that. I'll touch on it. I realize this audience might not be that interested in particular in US First Amendment law. And so I will make the case, though, that nonetheless, the time, place, and manner restriction concept drawn from First Amendment jurisprudence in the United States is nonetheless useful for thinking about governance models for friction in design and possibly elsewhere in the context of the speech environment, both for public regulation as well as for private governance or private regulation. So even, social media companies might think about governance of behavior on their platforms in terms of time, place, and manner restrictions when they're doing friction in design. And so I'll say a little bit about that. And then finally, time permitting, we'll see how much time we have. We'll talk a bit about the regulatory territory that's revealed in this paper, which is really one of the main goals, is to sort of open up this idea, open up the territory, the regulatory imagination. Here are a bunch of kinds of regulatory measures that aren't getting enough attention in terms of both interdisciplinary research about how they might work and how to design them, but also in terms of actually proposing and deploying them. Okay, so that I'll focus mostly on 1, 2, and 4, although I'll say a little bit about the third step as well. Okay, so Volker kindly mentioned the Reengine Humanity book. Susan and I certainly leverage the book and use it in the first part of the paper quite a bit. We rely on it. Same thing with Paul Ohm and I in our work. We're sort of relying on a lot of the ideas that Evan and I developed in this book. And I won't belabor all of them. I won't try to explain all of them to you. It's an incredibly complicated set of arguments that it took us 8 to 10 years to put together. And there's the book, there's a series of other papers and whatnot that sort of build from it. But what I'll try to sort of frame it for you a bit, right? So calls for big tech regulation, with which I'm sure everyone on this call is familiar, are often focused on things like antitrust, content moderation, and privacy, right? And while important, these are nonetheless, I would say, insufficient means for dealing with the variety of social dilemmas and significant social harms that arise in the digital network society. So none of the three address the rampant techno-social engineering of humans that's enabled by digital network technologies. Whether we're talking about electronic contracting interfaces that are designed to nudge people into automatically clicking, I agree, or the asymmetric use of friction in smartphone settings designed to maintain always-on geolocation tracking, or the deployment and seamless interconnection of supposedly smart devices that don't make consumers any smarter, but do afford intelligence-enabled power and control to others in our homes, vehicles, offices, schools, hospitals, and virtually everywhere else. Now, it may seem stark to suggest that the stakes are humanity itself. And this is actually a case that we develop at length in the Reengine Humanity book. I won't go through it fully here, but Evan and I framed the problem as a wicked global tragedy, the common style dilemma, where lots of incremental decisions about technology are perfectly rational on their own terms, but they fail to deal with a variety of external effects associated with adoption and use of those technologies. To say that the stakes are humanity itself, let me try to explain what I mean by humanity real quickly. So humanity may be conceived as a shared set of normative commitments or ideals about who we are and who we aspire to be, reflected in us, but also in our built world of imagined realities, institutions, and infrastructures, and really our environments that we sort of develop and pass on generation to generation. And this shared set of normative commitments is at risk of deterioration by pervasive techno-social engineering. And so we focus in Reengine Humanity, and to some degree in this paper as well, on specific forms of technosocial engineering that affect basic capabilities essential to human flourishing. So things including our various thinking capacities, the ability to socialize, trust, and relate to each other, our free will, autonomy, and agency. I mean, across cultures and generations, humans have engineered themselves and their built environments to sustain these and other core human capabilities. This contingent shared heritage is, I think, a viable conception of humanity, and it's what's fundamentally at stake in our digital networked society. So we frame the problem, as I said, in terms of this tragedy of the commons, which I'm happy to talk about in the Q&A if people are interested. I won't dwell on that right now. The root problem, one way to get at the problem is it's not really digital network technologies per se. And so in our book, Evan and I are not sort of Luddites or anti-technology, or, we're just critical, not of the digital network technologies per se, but rather the underlying economic, social, and political logics that have driven and continue to drive the development, design, and deployment of these technologies. Fetishized computation, a commitment to engineered determinism, a commitment to sort of amped up Taylorism extended outside the workplace and into a variety of other contexts, etc. One way to simplify some of these logics is to focus on a set of design mantras, with which anyone in engineering, economics, or law is probably quite familiar, and they're all listed on the slide, right? So maximizing, so when we're designing things, whether institutions or laws or technologies or environmental conditions, we ought to design things so as to maximize efficiency, minimize transaction costs, eliminate friction, seamlessly interconnect our systems when we can, right? Increase the scale and scope of engineered or technologically mediated interactions, and of course, democratize whatever, like fill in the blank with whatever you like, right? Democratize speech, democratize information production, democratize participation in X, Y, or Z. Whatever you like, fill it in, that's fine, as far as I'm concerned. Whatever's contextually appropriate for the design that we're talking about. Now, it turns out that each of these mantras is superficially defensible, much like a sheep herder's addition of a sheep to their flock in the tragedy commons, yet deeply flawed, I think, upon examination. Right? So human beings, and I'll do this quick, human beings are necessarily inefficient. We're not machines, right? We need friction in our lives. Seams, right? We don't want seamless interconnection all the time, right? Because seams are critical to governance. We need boundaries both for ourselves and for our communities. Interconnection often should be seamful, as that friction is what provides an opportunity or space for governance, collective or individually. Let's say growth in scale and scope, right? Often incredibly overrated, as there are often substantial hidden trade-offs involving typically externalities. Democratize, like innovation, has become a useless buzzword that hides considerations of power, quality, and meaning, among other things. And so, jump slide, there we go. So in this project, we focus mostly on friction. Because we've got to focus on something, and we're talking about friction design. So here we go. So the idea is that the relentless pursuit of frictionless transactions and social interactions in our modern digital networked environment is a driving factor behind surveillance capitalism, right? The extraction and monetization of personal data, and the creep of what we call digital Taylorism, which is the use of such data to scientifically manage most facets of our lives in order to efficiently deliver cheap bliss and convenience. To flourish, human beings need friction in their decision-making and their social interactions, because friction is resistance. It slows things down. In our attention-deprived world, friction affords us the opportunities to stop and think, to deliberate, and even to second-guess ourselves and others. Right? This is how we develop the capacity for reflection, how we experiment, learn, and develop our own beliefs, our tastes, and preferences. It's how we exercise self-determination. It's, in fact, free will and action. Plus, human beings are social beings, right? So meaningful relationships, whether intimate or professional or commercial, right? Meaningful relationships also involve and often require friction. And so in the paper, we explore a few examples. E-contracting is an easy one. I'll say a few, I'll use that one for a second just to sort of illustrate the point. We also talk a bit about social media. But if you think about e-contracting, frictionless e-contracting makes a mockery of contracting. At best, the e-contracting mechanism generates the illusion of consent through automatic and even programmed or scripted, heavily scripted behavior. Repeat interactions with this and other similar mechanisms risk habituation to mindless clicking. One solution, perhaps, is to deliberately engineer friction and transaction costs into human-computer interfaces and other digital network technologies. Right, so introducing friction in contracting is analogous to placing speed bumps on residential streets. So to be clear and to preempt an inevitable question that arises during Q&A, and you may be wondering about, let's just deal with it right up front. No one advocates for speed bumps on all streets, right? Speed bumps are deployed selectively to inject friction as needed to accomplish certain goals in very specific contexts, and the same is the claim about contractual speed bumps, right? They could be a feature of a website or human-computer interface to generate a time delay and require some form of labor by the user. There's a variety of different mechanisms that we could explore systematically, ranging from requiring people to scroll over certain terms to providing the most salient the 5 or 3 most salient terms to be read, to comprehension checks on the most important items in a contract. But certainly, we're not talking about speed bump and slowing down every single term of every single contract, right? Because that would just drive things to a halt. Let me jump. All right, so moving into the second part of the paper, right? Friction design. What do we mean by friction in design? What do we mean by friction in design regulation? So it turns out friction in design is actually quite common, right? It's common because it works rather well in serving instrumental needs. And a rather familiar example that we use in the paper quite a bit, though it's not the only one, is the speed bump, right? So any bump in the road adds friction for those driving over the bump, right? There's literally just friction associated with additional drag on the tires of a vehicle caused by a bump, right? Even if it's a stick in the road, right? Regardless of what the driver does, the friction causes the car to slow down some, right? How much depends on the nature of the bump. But in terms of speed bump design, right, that's not really the most relevant friction, right? There's also friction associated with other costs, such as shock, discomfort to passengers, wear and tear, damage to the vehicle, anticipated costs. These costs depend on the speed at which the car goes over the bump, but also the design of the bump, right? So a driver who thinks about these costs may moderate her speed, and indeed, research in many countries has found that this type of friction works. Speed bumps lead to reduced speeds, fewer pedestrian injuries and deaths. Speed bumps are essentially architectural features of a road designed to introduce a specific type of friction for the functional purpose of inducing behavioral change, such as speed moderation, and to serve the social ends of safety and public order. We develop, so as you see on the slide, we develop a set of questions, and I'm not going to walk through each of these. These are really to illustrate. We set these questions as a descriptive framework that can enable comparison and evaluation of different types of friction and design measures. And then we walk through a bunch of examples, including speed bumps. And we'll see on the next couple of slides, a couple of different examples. I'm not going to walk you through the speed bump example in considerable detail. It's in the paper. Happy to if people want to, but there is an interesting, I learned something when I spent months reading traffic engineering and civil engineering reports and research about speed bumps. And it actually was one of the most fun things I did this last summer. It sounds surprising, but I was an engineer in grad school before I went to law school. So it was kind of fun for me. But one of the things I learned about speed bumps that was kind of neat, communities deploy speed bumps to serve the general social ends of safety and public order, as I mentioned, and to solve specific problems of speeding and cut through traffic. Okay, so far so good. That's kind of what I expected. But here's the interesting thing is speed bumps are classified by transportation engineers as traffic calming measure And they're generally used on roads where there are both heterogeneous users, that is like, for example, vehicles and pedestrians, or kids playing or whatever, right? Or bicyclists. And also interaction effects among those users, right? So safety risks from one class of users for another. And these kinds of interaction effects often are a type of externality, right? So drivers on a residential street, like non-resident drivers, for example, may not fully appreciate the risks that they bring to bear to others associated with their driving speed, right? Communities deploy speed bumps. This is what I found interesting. I hadn't really thought of it this way, although this is related to something I wrote about in my infrastructure book back in 2012, right? Communities deploy speed bumps when they're committed to multi-use management of roads, right? So this is an important social value to note. Speed bumps encourage speed moderation by drivers and thereby afford non-vehicular users a certain degree of freedom to use roads safely. Now, you could, of course, not do that. You could say we're going to dedicate the road to a specific use. But if you want to have non-discriminatory sharing of a road, so you have multi-use management of that road so multiple users can use it at the same time and safely, you've got to manage the interaction effects, the externalities associated with interaction effects. And I had never thought of speed bumps as a way to do that until I read this literature and got myself thinking about it. So anyway, I wanted to make sure I drew that out in this talk. Let me jump. Another interesting example, this is sort of, this chart is kind of one way in which we took those questions, then we kind of visually sort of represent the information. So I'm sure all of you are familiar with Captchas, right? Completely automated public Turing test to tell computers and humans apart. It's an incredibly useful digital speed bump used ubiquitously online, right? It's an architectural feature of a website. It generally involves a time delay, time delayed access to a system. It requires performance of a task. That performance of the task serves a very specific purpose, right? It generates reliable evidence or proof that a user is a human and not a bot. It also, in addition to generating that evidence, it enables security measures when the test isn't passed and a bot is detected. It also, depending on the design, there's different versions of Captchas, but it can also generate data, useful data, based on the task performance itself. And when that happens, that may raise an additional, as we identify in the bottom of the chart, an additional kind of governance concern about, does that data go into a commons? Is it publicly available, or is it proprietary and owned by the company that's deployed the Captcha or the owner of the Captcha software itself? Like, there's a whole thing to get into there if you're interested. But the idea of what captures it. Oh, the other thing it illustrates is the scope of application. It's typically not an always on thing, but a triggered thing. It's triggered by the initial trying to get access to a resource. So captchas are useful. Captchas are not speed bumps exactly. They look like speed bumps in some ways, and in other ways they're more like a sobriety checkpoint. So in the offline world, sobriety checkpoints are another kind of friction and design measure, where access to the road, you've got to authenticate that you're sober. And so you've got to stop, which is the architectural friction, is to stop people at the road. And then in order to proceed, you've got to produce information. Like in the Captcha context, it's information that proves that you're not a bot. Passwords online is another example where you've got a knowledge-based authentication that you are the person you say you are. A sobriety checkpoint offline, it's you don't have to prove who you are exactly. You don't have to, but you've got to perform a task to show that you're sober. You generate information to show that you are entitled to use the road. So captchas are a little bit different than just a pure speed bump. Companies also employ friction and design strategically to serve their own interests. So, for example, in a paper I recently published called Nudging Humans, I examined the asymmetric use of friction and design in the iPhone geolocation services settings to set users on the engineered path of least resistance to always-on geolocation tracking. So I don't know if all of you are familiar with this. I sometimes, when I've given talks live, will have people do a little live experiment, have people turn out the phones and walk through this, because experiencing it is the best way to see it, but I can only show you guys pictures. But if you go to, turn on location services with your iPhone, it's pretty easy. Boop, you hit a button and it's frictionless, right? And not only is it frictionless, but you get that little green colored, signal that also sort of, has its own effect. If you go to turn it off, right? You want to go turn off your location tracking, right? There's an additional step, right? You not only have multiple steps, you also have these text warnings that are hard to read, but you also get the red color terms: danger, stop, don't do it. And so this is what I mean by friction in design that's asymmetric. It's asymmetric in the sense that there's friction in one direction, the path towards privacy, opting out of tracking, and the path towards not privacy, or the path towards tracking, is largely frictionless. So again, I won't go through this, but you can see how asking these questions, we can kind of work our way through, and we can use this as a comparative way to sort of think about different types of friction in design measures as they're deployed in the real world. Some companies have certainly tried to use friction in design to achieve social ends. And so WhatsApp has the WhatsApp forwarding friction. I don't know if you're all familiar with it or not, but this is an interesting example, I think. WhatsApp implemented a forwarding friction in design measure in India initially, and because there were a bunch of gruesome lynchings in 2017 and 2018, because there was false allegations of child kidnapping circulating virally on the platform. Right? Basically, it's a misinformation problem that causes significant harm and deaths. And so WhatsApp wanted to do something about it. And so they implemented this measure, this forwarding friction measure, in order to sort of tamp down virality. The company later extends this policy worldwide. So basically, the idea is messages that have been forwarded many times, 5 or more forwards, could only be forwarded to one user or group at a time. Of course, it doesn't stop. It doesn't say no more forwarding. It doesn't stop it completely. It just makes it harder. It injects some friction in the process of extending the virality or forwarding things. And then WhatsApp reported that the spread of highly forwarded messages dropped 70% after they instituted this restriction. In 2020, after false rumors, again, sort of misinformation about COVID, and it's linked to 5G, it's non-existent, but alleged link to 5G mobile networks, people began setting fire to cell phone masts in the UK. So WhatsApp tightened the restriction further and allowed users to share frequently forwarded content with only one chat at a time. And the friction essentially takes the form of a delay, extra steps, and effort to reach a larger audience. It applies to all messages. It's content neutral. An interesting thing that Paul Ohm and I there might be a separate paper on this, but the idea is what's interesting is what WhatsApp does has to be content neutral because of its end-to-end design, right? So WhatsApp is designed to be end-to-end with end-to-end encryption. It can't see the messages themselves. And so one test for content neutrality might be, could you implement it on an end-to-end encrypted system or not? So there's some interesting things there that we're going to explore. Okay. Friction design regulation. What do we mean by that, right? Hopefully I've successfully illustrated what we mean by friction in design. Friction design is deployed. Friction design regulation is what we're going to sort of move on to. It's not new. There's various offline examples: age authentication before you go into a bar, before you vote, product label and warning requirements in order to sort of provide notice and get people to stop and think before they make a purchase or do something. Friction in design regulation is regulation by the state that either directly requires friction in design measures to slow things down or to sort of force a certain task performance or authentication, or it might just require the functional outcomes. Again, authentication is an interesting one, that are pretty much best achieved by friction in design measures, even though they're not directly specified or required. So for the digital network society, what do we mean by friction design regulation? We mean state regulation of code, architecture, or interface design, right? It's regulation that requires friction with a functional purpose. And the types of friction are going to vary according to the context, what we're trying to regulate, the state regulatory purposes, the system what we're engaging with. Friction can be virtual speed bumps that cause delays. They can slow down interactions. They can require work, labor, task performance, thinking, deliberation, etc. Friction in design regulation could also involve different forms of nudging or social engineering, though they don't need to, right? That's just one thing that's possible. So we contend in this paper that friction in design regulation deserves more serious systematic attention by interdisciplinary scholars and policymakers, but at least in the United States, unfortunately, the First Amendment quashes regulatory proposals and regulatory imagination. And that preemptive effect may be especially strong in this case. Because again, friction design regulation, as we propose, would focus on code, architecture, and interface design. So what you can imagine, for example, legislation that required private companies to implement forwarding friction, like the WhatsApp restriction, or screen time alerts, or grayscale phone settings to get rid of that green and red on the iPhone setting I showed you before, or alerts prior to content sharing, right? This kind of legislation, if it ever passed in the United States, would immediately be subject to legal challenge on First Amendment grounds. And according to prevailing views, the legislation would likely be subject to strict scrutiny and struck down. So one thing that motivated Susan and I to write this paper was to sort of, explore a possible solution. And the possible solution, uh, really not necessarily like because we've got a specific proposal in mind that we want to advance to Congress tomorrow, but rather to sort of open up the space so that we can sort of start considering which of the possible proposals might actually be viable. We wanted to, our solution takes the form of sort of challenge the prevailing views, carefully crafting friction in design regulation so that it can be a form of content neutral time, place, and manner restriction. Because if it does, then it moves you into intermediate scrutiny rather than strict scrutiny. There's still going to be a First Amendment challenge, but it's going to be a little bit easier to pass muster in the courts. Okay. So the basic task in this part of the paper, which I'm going to go over pretty quickly, and I realize I'm at 30 minutes at this point, so I should probably give myself at max 5 or so more, because I want to hear from you. But Volker also said that you all want to stay afterwards and talk forever, so that's fine. I'm joking. So the basic task, you can see in this diagram, is to identify friction by design regulation that also qualifies as content neutral time, place, and manner restriction. Right? They overlap to some degree. In the paper, we discussed the TPM jurisprudence. You can think of it. TPM regulation needs to be justified without reference to the content of the speech. It needs to be narrowly tailored to serve a significant government interest, and it needs to leave open ample alternative channels for communication of the information in question. We go through this. I'm not going to dwell on this extensively. I think content neutrality is often the most important bar to constitutionality, like getting over that hurdle. And there's a test in the US on content neutrality that is this two-step test. I actually think for time, I'm going to skip over that for this audience. I'm happy to talk about in Q&A if people want to come back to this. What's maybe more interesting for this audience is to think about mapping TPM offline to online and thinking about what it actually means to do time, place, and manner online, right? So time and place or space, right, are limited shared resources, both for those who want to communicate with other people and those who want to use them for different, sometimes for unrelated purposes, right? So you can think about, I want to go to the park and convince Volker about, voting the way I think he should vote, or my candidate is better than his candidate, or whatever the political message I might be. And Volker just wants to, play soccer or football, I should say, right? He just wants to play football. He's like, I don't really I'm here using this space and my limited time in life to play football, and you want to use the same space to communicate your message to me, right? So those who want to broadcast a message share the relevant time and space with both willing and unwilling audiences, and time and place tends to deal with those. Manner, in terms of manner restriction, usually described, when we talk about manner restriction, we're usually talking about how people use the shared resources, right? So taken together, time, place, and manner are regulatory parameters for the governance of shared resources. So it's useful, I think, to distinguish, and we're exploring this in the paper. Again, with all the stuff I'm saying, by the way, to the audience, this is all work in progress. Like, I'm happy to get feedback both when we do Q&A, but also outside of it. So one of the ideas, we thought it was quite useful to think about 3 different types of externalities that give rise to social demand for governance in the context of shared resources. And this builds that. So they're listed on the slide for you: congestion effects, network effects, productive use effects, and interaction effects. And this draws on my infrastructure book from way back when. And I'll give you an offline example. Like, if you think about the tragedy of the commons, right? The classic story. I'm not going to walk everyone through the basics, right? Bunch of sheep herders share a limited resource, pasture, right? And Congestion effects, right? The external effects associated with the number of users and their sort of the rate of consumption of the shared resource, right? Each sheep herder adding a sheep doesn't accounts for the benefits, but doesn't account fully for the cost to the group of adding each sheep. And that the negative externality associated with the classic tragedy of the commons problem is sort of a congestion effect style problem. You get congestion, and if you pass some threshold, you get the tragedy that leads to the destruction of the resource. Like that's type 1, right? Type 2, productive use effects, you can think of, okay, well, the sheep not only consume the grass, but they also generate methane, bad odors, or, you know, they can generate other goods, public goods or bads, that also have another kind of environmental externality of a different kind, right? It's not because of how they consume the shared resources, how they generate some other public good that has effects, right? That's type 2. And type 3, it's a little harder to imagine, but bear with me. Imagine that sheep herders don't just have sheep, they've got buffalo or donkeys or something. It doesn't matter. Another animal, another grazing animal. And imagine that these different animals not only consume the pasture at different rates and not only generate methane at different rates, right? But they also fight with each other. Like if I add a buffalo to my herd, it increases the interaction effect, the rate at which the herd are going to get into conflict, right? Your sheep, my buffalo are going to run into problems. And so that's a kind of interdependence among use types that generates a different kind of externality. Okay, that's the offline example. For governance of shared resource that shape speech opportunities or constitute the speech environments, right? Time, place, and manner restrictions are suitable for the first and the third types of externality problems, but not the second type, right? So the first is a natural fit. It concerns managing the number of users and perhaps their speed or volume or intensity or rate. The third type is also a decent fit where there's a commitment, and this is a question, there doesn't need to be this commitment, but if there is a commitment to shared multi-use of the resource, right? So again, recall the speed bump discussion from before. The second type is a poor fit in terms of time, place, and manner restrictions for the First Amendment, because social demand for governance is generally going to be associated with the type of public good being produced by the speaker, right? And in this context, it will almost always be content-based. It has to do with what is being said, right? And so you're always going to run into the content neutrality problem. In online spaces, time, place, and manner can be understood differently from their offline meanings, of course, right? But they serve, and so we can think about, time. I've just used time as a quick example because I know that time is short. Our time together is short. But, in the offline context, time is kind of, you think of time restrictions, like when you can say certain things. You can't go down the middle of your street blaring your megaphones in the middle of the night, right? We all share time a certain way. Online, because of things being asynchronous, because of different time zones, time is often more a matter of delay or how long it takes for something to happen. So it can be different online. Nonetheless, time, place, and manner can be understood differently from their offline meanings, but the point is they can be useful as a system for governing the shared resources that we need for communication. Okay, so I'll wrap up with the next couple of slides. I'll go through them quickly, and then Q&A if people want, we can come back to them. But the idea is to explore the regulatory territory revealed. Time, place, and manner are parameters, not independent regulatory categories. And so the core theory is focusing on government regulation of the conditions of the environment within which speech occurs. Okay. So content neutrality will always mean that the regulation cannot focus on who says what or why, but it can focus and should focus on where, when, and even how. So one type of friction that will generally be worth considering are time delays. And the simple reason is that time is often the scarce resource. It's an essential input that we as human beings need to be able to think for ourselves, whether to deliberate, to contemplate, to account for consequences, to anticipate regret, to second guess ourselves or others, to decide how we use our attention, and so on. Another simple but no doubt contestable reason is that the marginal benefit of instantaneous communications made possible by the internet is often trivial. In other words, for most communications to, from, and among human beings, time delays do not necessarily impose a significant burden. Of course, it depends on the magnitude of the delay. Finally, another type of friction that will generally be worth considering are different types of work: labor, deliberation, active choosing, if you're a nudge person, right? There's a variety of things that we can think about there. Let me just focus on time delays and then I'll end. But so many, including myself, have celebrated internet affordances that enable near instantaneous communications to millions of people around the world at trivial marginal cost. This is what the internet has given us. Such celebration was most likely premature and overextended. There are very few, if any, situations in which communicating with millions of strangers needs to happen so quickly or easily. And there's nothing natural or sacrosanct about this powerful capability. So we might think about a regulation where digital communications that cross state boundaries need to be delayed by X milliseconds. Now, this might be a terrible, unworkable idea. Maybe not. I'm not going to defend it one way or the other. The only point is to illustrate it's one plausible type of friction in design regulation that's content neutral, time delay triggered by jurisdictional boundary, right? A modern TPM restriction for the digital environment. Why would we do that? Well, the slight delay could be aimed at reducing virality. It could constrain the scale and scope of digital communications among strangers, and maybe it would just enable a governance seam at the jurisdictional border. There are others. I realize that time is short. We're at the 40-minute mark at this point, and so I will wrap up by saying thank you. There's much more to do. This is a work in progress. I hope it motivates collaborative efforts among yourselves and others. And I want to definitely give credit and thank Susan, Paul, Evan Sellinger, and others who work with me on this stuff because that's what makes things happen.